Okay, so in the previous videos we discussed measures of central tendency in isolation and measures of dispersion in isolation. But in this video I want to introduce one statistic which is a combination of a measure of central tendency and dispersion, the so-called coefficient of variation. And I also want to show you a graphical illustration that also combines indicators of centrality with indicators of dispersion, the so-called box and whisker plot. But let's begin with the so-called coefficient of variation. The coefficient of variation is the ratio of the standard deviation of an indicator relative to the mean. It is a so-called relative risk indicator that has a lot of applications, especially in finance. And the coefficient of variation can be interpreted, as I said, as a risk indicator that captures the risk-return trade-off. And again, the coefficient of variation is widely used in finance as a risk indicator. So let's take a look at an example. So assume you have two stocks, A and B. So the standard deviation of the return per year of stock A is 20%, of stock B it is 5%. So it has a much higher volatility. So A is more volatile than B. But A also has a higher return on average, 10% versus 5%. So now if you take the ratio of the standard deviation relative to the mean, we get for stock A a coefficient of variation of 2, and for stock B a coefficient of variation of 1. So now what do we do with that information? Well, generally speaking, stock B is the less risky stock, because for each unit of return, that's how you can think of, you basically get 1 unit of risk. Whereas for each unit of return, you basically get 2 units of risk for stock A. And of course, on average, stock A seems to be the more promising, but it is also the more risky one. So if you are guided by risk aversion, you may want to go with stock B. And obviously, if let's say both stocks had the same average return, let's say both had 5%, well then it is obvious that you would, and so in this case the coefficient of variation would be 4. Well, in this case they have the same average return, but for each unit of return you get 4 times as much risk as for stock B. But if the average returns are different and you are only interested in what is the less risky per unit of return, you would clearly say, I want to go with stock B. So the coefficient of variation is an example that combines measures of centrality with a measure of dispersion, so namely the standard deviation relative to the mean, and it can be interpreted as a relative risk indicator. And there's also a graphical illustration that combines measures of centrality with measures of dispersion, and that's a box and whisker plot. And box and whisker plots are really very informative, and you can see them very often in data visualizations. So it's important to understand what you can see in a box and whisker plot. And what I want to do on this slide is actually derive a box and whisker plot from our data here. So we have 10 observations and the data is already sorted, and What the box and whisker plot does, it illustrates the 25th percentile, or the first quartile, the median, the 75th percentile, the minimum, the maximum, the mean, and also outliers. And that is important. An outlier is commonly defined as observations that are either 1.5 interquartile ranges above the 75th percentile or 1.5 interquartile ranges below the 25th percentile. Okay, and what I will do is I will use again the simple textbook version to quickly identify those values. Okay, so what is the 25th percentile? So we have 10 observations. So here the index, if I can squeeze that in, the index here would be 2.5. So that is not an integer. So we have to round up and we have to take the third observation, and the third observation has a value of 3. So here we have a value of 3. And I'll just say at 3 we have the 25th percentile. Okay, so 25th, I'll just make a dot there for a moment. So what about the median? So the median is the 50th percentile, so 0.5 times 10 is 5, that's an integer, so I have to look for the midpoint between the 5th and the 6th observation, so that's between 3 and 5, so that's 4. And I just put here a little MD sign for median. And of course, in different software programs, there may be a dot or a cross or a star. I'll just put here median. And to make it maybe nicer, I'll put a little circle around. So that's the median at 4. So the median is 4. The 25th percentile we said is 3. So now what about the 75th percentile? So the index number is 7.5. 0.75 times 10. Not an integer, so we have to round up to the next observation, so that would be 5. So the 75th percentile value is 5. So that would be here. Okay, so now what is the minimum of the data? What is the maximum? So the minimum has a value of 1. Just write here min, and the maximum is 12, so I put here max. So now we can also calculate the mean. So what is the mean of our data? So let's calculate it quickly. So we have 1, 4, 7, 10, 13, 18, 23, 28, 38, 40, 50. So the mean is actually 5. So I make the mean, I just write here, maybe x bar. Okay. So the minimum we said is 1, the maximum is 12, and the mean is also equal to the 75th percentile. Okay, so now what does a box and whisker plot do? So the interquartile range, which is between the 75th percentile, which is 5, that's the 75th percentile, and the 25th percentile, that gets a box. So I put here a box. Okay, so now we know that the interquartile range is the distance between the 75th percentile. I can write that here. 75th percentile, and this was the 25th percentile. So this distance is the interquartile range, IQR, and that IQR is equal to 2. So that is 2. Okay, so now, so we have the box captures the interquartile range, and now we add the whiskers. The whiskers are 1.5 interquartile ranges long, and they are displayed on top of the 75th percentile and below the 25th percentile. Okay, so the interquartile range, which we said is 2. So now 1.5 times 2 is 3. So now we put here whiskers, one whisker, which is 8. And we put a whisker here from 3 to actually 0. Okay, so because 3 minus 3 is 0. So now we see that the maximum value is actually an outlier because it is more than 1.5 interquartile ranges above the 75th percentile. We don't have any outliers below. So this is a very informative observation, and again we may have here the minimum, and typically you just see dots, and here's a dot for the maximum, and maybe the median is characterized by a star, and the mean maybe by a cross. And it doesn't matter, but the basic idea is that we can tell if there are like many outliers on top, then we can also already infer that the median, whenever the median is above, whenever the mean is above the median, which is the case here, then the distribution is skewed to the right. So many things can actually be inferred from a box and whisker plot. And so that was very detailed, and in most of the cases, it will just look something like this. So you will see a box. In this case, we said it's between 5 and 3. That's gives you the interquartile range. Okay, so the interquartile range is 2, and then you see the whisker of 3. Twice the interquartile range, and here, and then maybe the minimum is maybe just across here, and the maximum is maybe across there, and the minimum, the mean maybe gets a star here, and the median gets maybe, I don't know, another cross just like this. So you will see it something like this. So different statistical software programs have different designs, but the basic idea is clear. The most important thing is that you can identify the box and read that, and the whiskers, and then you will sometimes see, you will definitely see outliers and an indication for the mean or the median or both. We will do later when we talk about some real world data in Excel. The good thing is Excel actually does have a box and whisker plot feature that we can use, and we will review that later when we go into some real world problem sets. So yeah, so those were the two one statistic for a combination of measures of centrality and dispersion, the coefficient of variation, and also graphical illustration of the two in interaction, the box and whisker plot. Okay, so let's stop here, and beginning with the next video we'll talk about some measures of relationships.